Hello everyone. Welcome to the Blue Light AI channel. My name is Ashutosh Gupta, and in this video, I'm going to introduce our product Cobalt and its powerful UI. So let's get started. Let's start with installing dependencies. Then we download Cobalt using pip install Cobalt AI. In case you have already downloaded it, you may want to upgrade it. And lastly, we download the ImageNet dataset. Now let's import these libraries. Now let's identify our device. I'm on a Mac, so MPS is picked up, otherwise CPU is just fine. Now let's look at the data that we have here. So in ImageNet dataset, data is split in two parts, training and validation. For this introduction to Cobalt UI, we'll use the smaller data just to save time. Now we will load the paths of these images and also record their class indices for reference. Here is how the path looks, and here is how the class indices look. We will convert these indices into labels. So let's do that. So now we will get classes like this. We can see there are somewhere between 357 to 419 images. So now we are ready for generating the embeddings. So with our model now loaded, let's generate the embedding for each of the images. Let me speed up the video here to save time. Okay, so we are done. Depending on your machine, it should take between 1 to 3 minutes. So now we are ready to explore how Cobalt can visualize these embeddings, this data for us. There are 3 steps involved. First, we create the data frame with target labels, which we generated earlier. Then we load this data frame into a Cobalt dataset class, and then we add embeddings and we add image paths so that we can visualize it later. And then we add this dataset into Cobalt workspace. This is a key object that we'll be working with. So our workspace is created. Now we are ready to create our UI. This takes a second. Okay, so our UI has been created. Let's take a look. This Cobalt UI has 3 different parts: landscape, data groups, and data table. The upper left half is the landscape. This landscape is constructed using the provided embeddings of the images and not the raw images. Each node here represents a bunch of similar images. Edges between these nodes connect these groups of similar images. We can select nodes here and view them in the data table or save them as data groups for later analysis. This upper right half contains the data groups. We see that already 15 groups have been identified here by Cobalt's default settings. Any group that we select here will be highlighted in the landscape, and corresponding data will also be loaded in the data table. This is a button to create new groups and save them for later analysis. List of these saved groups will show up here. Lastly, this lower part is data table. This data table displays the data corresponding to the nodes selected in the landscape or in the data group. Right now, nothing is selected, so data table is showing the entire data set. Now, let's look at the options available in our landscape. On top, we have option to select graphs. Currently, we have only one graph. Then we have coarseness slider, which allows us to adjust the number of nodes in the graph. Reducing the coarseness to 0 will increase the number of nodes to a maximum. In this case, one node for each image. Increasing the coarseness will reduce the number of nodes, but increase the number of images within each node. Then we also have connectivity slider, which allows us to adjust the number of edges among nodes. Edges or connections among nodes indicate similarity among the data points associated with those nodes. Now we have coloring options for our graph in the landscape. We can choose to have no color map, or we can choose to color based on any column in the Cobalt dataset, or we can choose to color based on one of the clustering results, which is what we have right now. This option here allows us to choose from the available color maps. Lastly, let's take a look at some of these options here. This button allows us to zoom in. Using this button, we can zoom out. Here is the reset button to display the entire landscape. Here is a button to expand the landscape view. If we click it again, then we get back the original view. Here is the lasso select tool that allows us to make a manual selection. So maybe let's look at these two groups here. They are in different clusters. So let's select them. Let's also save them. Let's give them a name. Let me call them twin group. So our group is now saved. We can look at it later. Here is another way to select using this box selection tool. Again, we could save them as a group if we wanted to, or just look at them in the data table. This button allows us to clear the selection. Note that you can also double click anywhere on the landscape to clear the selection. Apart from the lasso and box select options, we can double click on a single node to add or remove it to a selection. So if we double click on an unselected node, that node will be added to the selection. If we double click on any selected node, that node will be cleared or removed from the selection. Here is a button to invert the selection. To show this, let's select some region again, and hitting the invert button will invert the selection. Lastly, we have this play or pause animation button. Currently, this button is in the play mode. This means that if we pull on any part of the graph, it will pull all the connected nodes. So the graph is reshaped in a dynamic way. If we were to hit the pause animation button now, this dynamic animation will stop. Now if we pull on any node, only that node will move. If a group is selected, that only that selected group will move. This helps many times when we need to examine nodes that are difficult to access or hidden from direct view. Surely we can hit the play animation button again to restart the dynamic animation. Now let's utilize some of this information to do a little bit of exploration. First, we see that the default color map has 10 different colors, but we have these 15 different clusters. So let's change the color map. Now let's say that we want to study how these clusters are connected to each other. So let me pause the animation and start from one side. Let's say we start here. This is cluster 4 corresponding to golf images, and one node here is connected to a single node in cluster 2. We can separate them and see that it's likely this greenery that is connecting them here. Remember that this is unsupervised learning. Similarly, we can separate other groups and explore. We can also look at this twin group that we created. We see this is made up of two clusters. Both of them are from the same tench class, which is a fish. But in one cluster, most of the images are people facing the camera and showing the fish, while in the other case, there are general images of the tench fish. We can also further explore any of these groups using Python. Running getGroups function returns a dictionary of groups that we created. We can also pull up data for our twin group like this. We can also explore those auto clusters created by Cobalt's default settings. We see that there are 15 clusters. We can look at any specific cluster's data or view it in a table. Please feel free to explore and try out more things. Link to this notebook and the Cobalt documentation page can be found in the description of the video. Do let us know if you have any questions or comments. Thank you.